Hey there, it's Dave, and this is a rehearsal of an experiment for Quarantine Science Lab. We're here in the Marie Ferreira Memorial Outdoor Lab. It's lovely. We have a little bit of some lab grade 6 molar hydrochloric acid. Okay, and we have some bleach that is disinfectant bleach, and I don't know if you can read that, but it is it's a higher than normal percentage of sodium hypochlorite, which is bleach. It's 7.5% instead of the typical 1.6% or 2.7%. That's used for clothing, and not a lot of other ingredients, and it's pretty pure. From my understanding, it's pretty pure bleach. And we have also on hand something a little more exotic, which is some, let's see, first I got to get my safety glasses on. All right, that's much better. Safety glasses. They're a little dirty. I'm going to clean them up a little bit. Who's watching? Hey, Dave. How's it going? So this is just a rehearsal for an experiment I want to do with my kids later tonight when it's dark, or another night when I have a shipment of hydrochloric coming in that should be here tomorrow. So I also have here a good supply of something called calcium carbonate. I'm sorry, calcium carbide, not calcium carbonate. Calcium carbide. And chem people probably know right off the bat that this is something that, not that it's flammable, but that when it's mixed with water, it produces acetylene gas. But today, before I mix it with water, I am going to mix it with, first I'm going to mix the hydrochloric acid in the bleach. And what we're going to produce is actually going to be chlorine gas. But there's going to be a lot of water produced as the hydrochloric acid and the sodium hypochlorite mix. They're mostly in water, but as they mix, they are going to produce chlorine gas. And guess what else they produce? Table salt, sodium chloride. So, and the rest is water. So if I were to put calcium carbide in there, it's going to react with the water and it's going to produce acetylene gas that's going to be in a chlorine atmosphere. And what I'm thinking is going to happen there is there's going to be some sparks, as you can imagine. So what I'm going to do is just, this is less than 20 milliliters. Just going to put some of that in there. All right, that's enough. It's about 8 milliliters. And now, where's my bung? I have my bung handy. I'm going to keep that in there, and I don't want to pour out this hydrochloric, so I am going to deliver this with a dropper. There we go. And I expect that we'll see, we'll see a reaction. You see the reaction going on there? I'm going to give it a little bit more hydrochloric. The hydrochloric acid, the chlorine gas that's being produced is going to be heavier than air. So it's going to stay inside the test tube. I'm hoping it's going to be visible. Oh, there we go. Do you see a little bit of greenish yellow? This is greenish yellow, but up here, the gas that's being produced, also a little bit greenish yellow. I'm going to double check that my hands are dry. I miraculously did not get any on my hands. Put this out of the way. I'm going to put this out of the way. And now there is sodium chloride being produced there, but it's dissolving in the water, so we can't see it. There's still a greenish yellow tint of bleach there. I may need to put more hydrochloric acid in there. I'm trying to conserve what little bit that I have in case I want to scale this up tonight before my other shipment gets here. Might need to put a little bit more. I'm going to try a little bit more. All right, that did not kick up much of a reaction there. It's continuing its reaction. Didn't really kick anything up. It's not terribly warm. I'm gonna take it out. I'm gonna shake it a little bit. There we go. Whoop! Now we got that lid popped off because it is producing gas. So I'm gonna grab that. Both of these lids need to be washed now. I'm not sure which one it was. I hope we didn't lose our chlorine gas there. Now, all right, now comes the good part. You guys ready for this? Y'all ready for this? Da, 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 da. All right, so I'm gonna go with a, sit down, sit. That's a good girl. I'm gonna go with a medium-sized chunk of the calcium carbonate. Okay, it's like a rock, but it has been produced in a laboratory. I'm not gonna push the stopper in real strongly. Just gonna leave it in there. Oh, nice! That's exactly what I was looking for. That is exactly what I was looking for. And I'm so glad that it did not overflow this. Are you guys seeing this? Oh, that is wicked cool. That is so exactly what I was looking for. I can't believe it. That's acetylene gas and chlorine. That it lights all on its own without any, it's still lighting. You see that? You see that? The boundary between the chlorine gas and the acetylene gas is lighting there inside like a plasma. Oh, that was so exactly, did I jump? I don't know why I jumped, because it's exactly what I was hoping for. That is wicked cool. I don't smell any chlorine. It's still combusting in there. Oh, this is awesome. Each time I light it, it continues to combust because we have a layer of chlorine or acetylene gas, and I don't know which one's on top, but I guess the acetylene is on top. Once it starts reacting and combusting with the chlorine gas, it continues on its own. That is so cool. All right, should we try a little bit more? Should we try a little bit more in there? Dave, you still watching? Now, there's a lot of buildup there. I'm not sure there's any more chlorine gas in there, but we'll see. It looks like there's no more chlorine gas left. I think we've exhausted the bleach hydrochloric acid reaction, and now it's just water, salt water, and acetylene gas being produced. So if I light it, it will light, but it's not going to light by itself. That was from my ignition a second ago. It's still burning, if you can see it in there. All of those bubbles contain acetylene gas. Oh, yes. That's exactly what I was looking for. So now, tonight when it gets dark, we're going to film an episode of ta-da, Quarantine Science Lab. And we're going to do this experiment we're going to scale it up. And this is, I have this much hydrochloric acid left, and I have a ton of bleach, and I have a ton of the calcium carbide. So we're going to scale this up, and we are going to make fireworks out of doors. I'm not going to go crazy and scale it up like 1 liter. I'm going to scale it up to just probably the same amount, but in a bigger bottle, so that we can see, I'm going to hang it here, we can see more fireworks. Since I know it's going to work, I'll probably just use half of this and the same amount of bleach. Actually, I have time to go research exactly what's the perfect combination of bleach and... See those bubbles in there, those suds? Those suds contain acetylene gas, and they are going to continue to be explosive or combustible as long as they stay there. So until I pop all those suds, I'm going to have to treat this. Ooh, that's hot. Of course it's hot. It was burning. I'm going to have to treat this as acetylene gas in storage right there. So, let's see. What if I put a little more bleach in there? Not sure if I should try that even. Explosive. Now, the acetylene gas burns. In the past few seconds, you've seen, well, that last explosion seemed like chlorine mixed with acetylene gas, although they shouldn't be stable. But the acetylene gas, when you burn it in the presence of air, it goes boom, poof, right? It burns, and it makes a little poof sound. If there is oxygen, a high concentration of oxygen, or a high concentration of chlorine, it will either ignite on its own, or it will make a bang. Like the bang sound you hear sometimes when you light something, that is a supersonic explosion. That means the gas is combusted and expanded at a supersonic rate. And that's why it makes a bang instead of a puff, okay? The same applies to gunshots. Some gunshots are subsonic, and they make a bang, a sharp sound, but other gunshots make a snapping sound, like pew! That's a supersonic bullet passing through the air with an explosion. So that's the difference in the sound of explosions. Some explosions are subsonic, other explosions are supersonic. I don't think we have anything more to get out of this, although there are suds in there. What if I pull those suds out? I wonder if I can do that. If I can pull some of those suds out. Oh, I can, and I will, and that's all acetylene. Those suds are stubborn. They are not burning. I'm going to put it here. I'm going to scrape off those suds. Those suds are almost like solid. That's my dirty jar. This soot that you see, that black soot, that's all in here and it floated through the air, that is a calling sign, the signature of acetylene gas burning. I can't get this to burn. Very strange. Let's see what we got here. I know there's acetylene gas trapped inside these suds. I know it. And it may be mixed with chlorine, but I cannot get that to burn. I'm expecting a little minor fireball there. It's not happening. It's almost like it's a solid. That is very strange. I smell the acetylene. I smell a tiny bit of chlorine, but it's just acetylene in there. I don't know how to get it out or make it combust, so that's not the objective today. I'm going to wash this stuff up. I'm going to wash this. Hey, look at this little spider here. Come here, bud. Where'd you go? All right. I have some washing to do. Thanks for tuning in. I will be back later tonight, and we are going to do some more experimentation.